actually decide to learn Splunk is not that stuff, but it is boss of the SOC. That's the fun stuff. So you go here, and boss of the SOC is here, and you can make enough points here to ignore everything else in the course. The whole course only has by the way, I should mention, I put up the score rubric today. So let me go there to Canvas. Okay. And I realized I hadn't put up the scores, so I put them up now so you can all see. You should never be in any mystery of what grade you're getting. So I put the scoring rubrics on all my classes. So here's how it goes. It's in the announcements, final grades, okay. So that's it. There's 320 points. You need 288 points to get an A of any type. And there's quizzes, there's these projects, and there is boss of the SOC. And boss of the SOC is 300 points all by itself. So you can just totally ignore everything else and just do boss of the SOC if you like, and that would probably be the most fun. All right, and so I'm planning to do the first bit of this. And this, you don't have to install a Splunk server. You're going to use my Splunk server that I've already set up because it's already got a whole bunch of data in it. So, and there's an automated scoreboard here. So, let's see how people are doing. A bunch of people have already done quite a bit of boss of the SOC. Good for them. All right, so if you have to my server, I have two of them, splunk.samsclass.info and splunk2.samsclass.info, just because sometimes one of them is down, because of course, you're all using the free version, which means you're all the administrator. So each one of you can trash it, and people do. So I restore them from images and stuff. The student one and student one is the password to get in. I mentioned that warning, the clock is wrong on the server. It's upset about that. And then there's a bunch of extra add-ons here, but none of them matter. The only thing we're going to use is search. Plain old search. All right. And in fact, I think I want to do this in Opera, where it'll look prettier. Let me do it there. Boss of the SOC, Splunk 2, student 1, and student 1. All right, time is wrong on my server, search and report. Okay, now we can search for things. I'm waiting for the data to pick up. It shouldn't take too long. Maybe famous last words, we'll see. Oh, there we are, about 1 million events. By the way, my Splunk 1 server now has like 1.07 million, so somebody managed to add extra data to it. I don't know how, but there's always something. You know, with everybody running as administrator, the servers do get sort of messed up. But anyway, all right, so if you go to data summary, you'll find out what's happening. And as I mentioned, it's more than 5 years ago. 7 years ago is the earliest event. All right, so here, if you click on data summary, you'll see what data is here. This is what you did at the end of last week's project. You uploaded 3 files, and the data summary showed 3 sources with boring normal logs. This one has more. Now, by default, it gives you the host name, which might mean something if you were at this company and you knew what the hosts were named. But for us, the most useful information is source type, which is what kind of data. So here's Windows event logs. That should be pretty clear. The event log is the default logger on the Windows systems. Here's the Windows registry, and here's Sysmon. Sysmon is fantastic. Sysmon is a free tool from Windows internals, part of Microsoft, and it creates extra event logs that are very easy to understand. The normal Windows event logger creates way too many entries and they're hard to understand. Like if you just open a folder and open a file in Notepad, that's like 100 log entries, meaning baffling little details about how you open a folder. But in Sysmon, it would be 1 entry, type 1, opening a file, something like that. It just has like 10 types. A network connection, launching a process, opening a file, and it stores all the useful information like the MD5 hash of the file and stuff like that. So it makes it very easy to understand and quickly find out what's happening on your Windows machine if you use Sysmon. FortiGate is a firewall, and the FortiGate has some logs that are being forwarded. They have a Windows web server, IIS, and its logs are going up to the Splunk server. And here's, of course, some kind of Nessus scan, which I don't think we're using. I don't know what that's about. But here's the stream data. All the common protocols, it is sniffing the network and finding the data. The one we're going to use mostly is HTTP, although for some of them we're going to use the DNS log. But this is this is not like Wireshark, where it stores the complete packets. It stores a summary of every HTTP event. Like you connect to a server and you download something, and that is 1 log entry. Went to this server, downloaded this thing. And then There's more at the bottom, which somehow I'm not successfully scrolling to. Let me make my window smaller or something. All right. Oh, I guess, no, it's down there. It's not letting me get to it somehow. Stream SNMP. Wonder if I can use the, all right, I'll just shrink this. There, Suricata is at the bottom. Suricata is an intrusion detection system, an open source one. So it detects known malicious data on the network and raises alerts. And we're going to use all these things. So and the way they did this is the Splunk paid for some of their staff to spend a few weeks setting up a whole server setup in Amazon with a fake company and all these servers, and then attacking it with the common attack tools and getting all the Splunk data and archiving it all so you can have a contest finding things there. And what we have here is the minimal data set with only 1 million events, and all these are malicious events. The original one had 10 million events. Most of them are innocent traffic. But I didn't think my server was powerful enough to handle that, so I went with the smaller data set. And it's good enough to get some fun practice. So that's the kind of data we're going to be searching. Now, technically it all is all indexed. And the index is BoTS v1, boss of the SOC v1. Now, you don't really need to put in the index because there is no data except this one index data. But in general, all the documentation says be sure and specify the index all the time, because at a real company, you have multiple indexes, like this location, that location, accounting, high security, different areas, and telling it what index you're searching is good. So if I search here, I'm going to find 0 events. So what's wrong? Time. It's 7 years old. I'm not going to find it in the last 24 hours. So I could change it to all time. Now, if I change it to all time, I'm going to find 1 million events. And here's a fun fact. The time it takes to do the query depends on how much you find. When you find a lot, it's going to take forever. So before I do that, I'm going to switch it to sampling. I only want to see 1% of them, a random 1%. Now I can search for something with a lot of results without it taking too long. So I'll go to all time and search. And now, instead of 1 million, I'm going to find 10,000 events. Okay, here's a random 1% of the events. All right. Now, I'd like to look at the web traffic. So I could remember the thing and type it in here, but that's for the birds. You don't pay for Splunk, so you have to remember and type. If you go back, I'm going to go back here and go back to search, get a clean, empty search, and now I got this data summary. And this is why they highlight everything in blue, because you can just click on it instead of typing. So if I go to source types, one of the options was stream. Yeah, it's there too, right. So I go to stream HTTP is one of the source types. And SNMP, there it is, HTTP. If I click it, it fills it in for me. Source type equals stream.http, and I don't have to spell it right or remember the quotes or anything. Okay, now it found 0 because I'm in the last 24 hours. That's fine. I'm going to turn on the sampling again and go to all time. And this is going to be all the web traffic on the network. And so found 261 events. Now, I could look at the events one by one. This is table view, which is pretty unhelpful. I'd rather see it in another view. This is raw view, which will just show me the raw log line. That's also annoying. The list view is usually the friendliest. Now it highlights the fields with red names, and so I have accept, bytes, client IP. Here's the destination content. So it looks like that's the start of a web page. Doc type. This is not a 404 error. Yeah.
This is sort of off topic, but is there a view option that is not red and green because it's hooked up for colorblind folks?
It's a very good question, and I don't know the answer. I imagine you could change it. Everything in Splunk, there's just text files with all the configs. So it's probably not in the GUI, but you could probably go in those text files and change the colors. If you actually go under the hood, especially on the Linux version, it's really simple and clear. So when I get fed up, like for example, to import this data was nearly impossible. Their instructions were baffling, so I just ignored it. And I found where the data is stored and what file to copy, and I just copied the file over. And then the hard part was changing the permissions. But what's inside here, it's actually very simple. And it's just like standard Linux software. There's some config files that have everything. And also there's a huge community of Splunk users and hackers posting blog posts and everything. And they'll often tell you, go to the command line, go to the config file and change it. Yeah. It's all very configurable. And like I say, if you do that, you're getting close to like the Linux people that just use Elasticsearch, which is, and then you control it all. The only difference, as far as I can tell, between Elasticsearch and Splunk is Elasticsearch uses SQL and Splunk uses Splunk query language. But anyway, yep, this is a very good question. All right, so here we are. So this is the result of a query. Here's some requests. This is the source header. So it tried to get a script with a funny name, not too exciting. You just scroll down and look at what else it did. Here's a destination content. You just look at a few of these. Pretty soon you'll find something malicious because most of these are, this is getting a login. That's relatively harmless. This one here is getting a 404 not found. Here it is. Get this page should not exist.htm. You know, that's looking a little suspicious. Why would you try to get this page should not exist? And the answers will be pretty clear before long. User agent, Pragma. All right, I'm going to try just a couple more, and then I'll just find a way to zero in on it. I'm expecting.
Looking for the traversal, right?
What I'm looking for is obvious attack traffic, and then we'll see that it came from a vulnerability scanner. It looks like you're trying to access MongoDB. Get user agent accept. All right. So let me try getting rid of the filtering. Let me just check my official instructions here. But when you're doing filtering, you get random events. You don't know what you're going to get. I think if I turn off the filtering, I'll easily find what I want. So let me try that. Where's the Splunk? I'm losing my mind. Here? Wait, I'm in the wrong browser. This browser, there we are. I've lost it somehow. Boss of the SOC. Thought I had it open in, well, this is Brave again. Okay, there we are. It should be here somewhere. Here. There. All right. So if I get rid of the filter and just see all these HTTP events, that's reasonable. I have 261. If I get rid of the sampling, then I'll see 261,100, 26,000 events. All right. And see the timeline here, happened in 2016. All these events were apparently on the same day in 2016. And now, here we are. I get some kind of binary data, and that's destination headers. Here's the source headers, trying to get a product, okay. I shouldn't have to hunt too far to find obvious attack traffic. That's what I'm expecting to see down here. Get Windows compatibility. I don't know what that garbage is. And, okay, I'm getting annoyed here. I'm going to view just the source headers to try to spot them. Usually I can easily find a malicious one, but today I'm getting troubles. And let's see if I can find source headers here. There, source headers, there. So get Joomla, post Joomla. Yeah, there's Joomla server. These are all ordinary ones. Notice, here's what I was looking for. Acunetics user agreement, web vulnerability scanner. Some of these things came from the Acunetics web vulnerability scanner, and that is clearly attack traffic. The bad guys ran a vuln scanner on the website. Then they found the vulnerabilities, then they exploited them. This is how you normally do it. And the company doesn't run a vuln scanner on itself, not in normal production. You do that. So you'll find it before. There are some that have this Acunetics web vulnerability scanner. So I just want to see one of them. Now, an easy, sleazy way to do it. These are all going to have the name Acunetics in them. So if you're too lazy to use name equal value, you can just add the word Acunetics to your search. And you'll find log entries that contain that word. There. And there are a pile of them. There, 2,500, and there's more coming. It's not done until you see a green check mark. 5,000. And I think it's probably done. The check mark should be coming. Nope, 17,000, 20,000, okay. Okay, 20,926. Notice the timeline. On August 10, they started the scan at 2:36, and then it looks like another batch of scans tapped at 9:41. Looks like they ran the scanner kind of slow, so it took like a whole day to scan. That's not a bad idea, actually. You can take down servers with your scanner. Anyway, so now the point of this is all this must be coming from the attacker to my web server. That's what they're doing. So even though I have 20,000 events, if I look at the destination IP, they're almost all the same. One outlier. So this is apparently the web server, the destination, and these are facts you need to know. So you make a notepad file somewhere, keep notes. All right, so the web server IP. The scanner is Acunetics. The web server is this number. And the attacker will be the source IP, which will show up here. I had client IP probably. Yep, that's the client IP. All these events came from this one address. This is the machine that was running the vulnerability scanner, so that's obviously an attacker. There. So those are the first several flags you got to find. And so there's lots of ways to do it. But if you look here, I have instructions how to find some of these. Extreme equal HTTP. And, all right. Oh, that's what I forgot. If you want to just be filtering the events that go to the web server, you could put in the domain name. I'm really not Batman. That is the name of the company web server. And so if you add that, you'll get only queries that are going to their server. And then I think if you don't filter, the very first one is obviously an attack packet. Let me see if that works, just so I can be consistent with my previous procedures. Yeah, the first one is obviously an attack. Look at this. It's trying to do SQL injection. Select 0 from select sleep, select 20. So this is obviously not a real customer trying to do something. This is obviously an attacker trying to do an injection. That's what I thought. I forgot to put in the domain name. Stuff going to the web server, the very first packet going to the web server is in fact the attacker. And so once you do that, now you have the source IP as the attacker, the destination IP is the web server, and you know the brand name of the scanner because it will put it in most of these attack packets, although not that one, but I think the next, pretty soon it'll show you that Acunetics header. Yeah, this is because the scanner typically adds these extra fields to every request because they don't really want it to make it hard for your security team to filter this out. They expect you paid for the scanner, you want to scan, and they're not trying to hide or anything, they're trying to make it easy to detect stuff that came from the scanner. All right, so that's the point. Now you found a few flags. So first one was the scanner name, then the attacker's IP, the web server's IP. So the first 3 flags we've all found from the first significant attack event we found. And so the way you get your points is 1.1 is the scanner name. You go to the top of this and submit flags. 1.1, I'll put in the special name that won't go in the scoreboard, and that was Acunetics. Submit, and it tells me I'm correct. So that's where you turn in flags and get your points. And as you go on, you will have a score here. And like I say, these guys, if they're in this class, they've already gotten A. Although if you use a fake name like that, you'll have to tell me who you are. But you can just turn in a picture of the scoreboard in Canvas and tell us what name you're using, and you'll get your points there. All right, so anyway, now let's do a couple more of these. So the first 3 all came from the very first malicious event we found. The attacker's IP, the web server's IP, and the brand of the vulnerability scanner. So now that we know that information, we can proceed to some more fun stuff. The next thing is the defacement file name. This is where you begin to see the power of Splunk. In a properly designed network, the server can only be a server and never a client. What that means is you can make a request to the web server and get a response, but the web server can never make an outgoing request. That should be blocked at your routers and your firewalls because there's 2 reasons. You don't want anybody going on the server, opening a browser and downloading stuff because they'll probably get infected with malware or something. And if you want to put a file on the server, you don't download it directly to the server. You go somewhere else, download it, scan it for viruses or something, and then move it over with FTP or something. That's the right way to manage a server. And when attackers attack you, what they typically do is send you a phishing email or something, get you to click on a link or open an attachment. Then they make a reverse shell, because the Windows firewall will typically block incoming connections. So the typical way an attacker attacks you is you run code, the code makes an outgoing connection to the command and control server, and then you control it remotely. So if you block outgoing traffic, block outgoing connections, you prevent the attacker from being able to get a shell on your machine. Even if it has a vulnerability and they're able to execute code, they can't phone home. So it is basic network hygiene that your server should not be allowed to be a client. So the question here is there any traffic going backwards through the network? Now, the way you do that, so we have a Splunk query here that's finding HTTP requests. And we would like to know, did somebody actually make an HTTP request from the server? So I'd like to find the client IP. Now, I could type it in, but that's for the birds. You go down here, and here's client IP. All right, I'm just going to click either one of these. It doesn't matter because I want it to let up the format for me. So now I'm getting web requests from that client IP, and I want that client IP to be the web server's IP. This is what should never happen. The web server's IP that we found earlier should never be a client IP for an HTTP request. So I put that in there and run that, and now I get 0 events. Now, this means that it never happened, right? But there's a problem. Did anybody spot the problem?
Yeah, you put
I left the domain name in here, so I'm only looking for web requests to this server. But now I'm looking for requests from that server. It would be going to a different domain. So I have to remove this. I want any domain from this server. That would be forbidden. This is any kind of HTTP request going to some other thing like Google or Yahoo or something from the server. So if I do that, Splunk immediately finds the tiny number of backwards events. There are only 8 or 9 events. It found these 9 events out of 1 million that easily. These are the 9 times traffic went the wrong way through the network. And these are really important. And now there's only a few of them. I can look one by one. If I go down here, this is some kind of binary thing downloading. And if I go down, I can see the request that made it. There, get poison ivy is coming for you, batman.jpg from host prankglassine_jumpingcrab.com:1337. So this is obviously a malicious server running on port 1337 like hackers often do. This is the staging server on which they've stuck malicious stuff, and they are now downloading this image from there to deface the web page. So they got a shell on my web server. My network did not have proper traffic control, so they were able to make a request from their web server and download junk onto it, and this is a request downloading some of that junk. So this is the next couple of flags. If you go back here, the defacement file name is the name of that image, and the domain name, the fully qualified domain name, is that thing with Glassine Blackett in it. And so that's it for the first batch here, which is much I wanted to show you today. You should try that stuff, and I see we're right on time, coming around to 7:30. So I think this is the thing to do, so play with that. If you're taking CNET 50 and 152, they both use this project, and you can just do it once and turn it in for both classes. It won't hurt you to learn Splunk. All right. So I'm going to stop this recording. Oh, and go check the